Welcome back. This is lecture 15, procedural recursion until binary search. It's a short lesson actually. Covers sections 11.3, 11.4. Although it is a short lecture, it has many important things for us to learn, guys. So make sure you pay careful attention to the lesson, to the videos. Regardless, all the relevant files have been uploaded in our Blackboard account. Where do you find it? Go to content. You have codes for lectures and lecture 15 files. All right. Now, they are also uploaded in our weekly files of class notes in Dropbox. Okay. So, procedural recursion is also called functional recursion. Recall factorial of a number n factorial means n times n minus 1, so on until 1. N factorial is n times n minus 1 times n minus 2, all the way until 2 times 1. So you are counting down. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, all of 120. Notice 5 factorial can be written as 5 times 4 factorial. Okay. By the way, by definition, 0 factorial is 1, 1 factorial is 1. This is to be taken, okay, as a definition, part of the definition. So 5 factorial is 5 times 4 factorial, generally speaking. N factorial is n times n minus 1 factorial. This is where you get the recursion. Factorial definition relies on factorial definition. Okay. So here is a code for it. Define factorial n. If n is less equals 1, that is if n is 0 or 1, factorial should be 1. Otherwise, that is else, return n times factorial n minus 1. Each time a function is called, the system creates an activation record to track the state of that particular invocation. In the context of recursion, each individual call to the function executes the same body of code. All right. For example, to find factorial 4, you needed factorial 3. You needed factorial 2. You needed factorial 1, and then you return. This is called trace of a call. So how do you trace it? Tracing is an important skill. It helps you find mistakes, helps you find inefficiencies. Let's look at an example. So I have applied trace to all the codes we had worked on in lecture 14. To start with, star triangle. So where is star triangle? So there you are, star triangle. If you remember what it does, let me remove one new piece of code there, that one line that I had added. So run it. Let me remind you. Notice I'm only considering the recursive version. So enter a positive number. So say I enter 6, I get a triangle of stars. 6 lines, 5 lines, 4 lines, 3, 2, 1. Notice it doesn't tell me how my program ran. So I've added just one additional sentence to my code from lecture 14. That sentence is added right in the very first sentence, very first line in the definition of print triangle. Okay. Notice print triangle n is what I have repeated here. Except for my input, I have made everything else a string. Now let's run the same code again. So just one additional sentence. 6 is my input. So this is the trace. So when I invoked print triangle 6, it drew one line and invoked print triangle 5. Draw another line, invoked print triangle 4, 3, 2, 1, and so on. So that's where if you had to draw, and you should be able to draw a trace diagram like this, now you know what goes here. Instead of factorial 4, you have print triangle 6. then you have print triangle 5, and so on. And the number inside is the argument inside, you see. And now you return one line star, 1 star. Here you return one line with 2 stars and a line behind. So you see, that's how you have built up the output. Okay, so here is another example. The second code is palindrome tracing. So let's look for palindrome with tracing. Here, let's again write the very first sentence in the definition of is palindrome is a print statement. This allows us to see how the code works. So let me comment it out first and you can see what it does. Let's run it. Let's take an example of a palindrome, madam, right? It's reflective, right? Okay, it's telling me my string is a palindrome. Okay, so we got an output, but we didn't see how it checked. Let's run this with the commented statement open now. Notice what was this print statement. Print the same definition inside except for the input, right? Everything else is a string. The input alone is a non-string object. Whatever input you get, the parameter, it stays as it is. The rest is a string. Now run this program with the same input, madam, and here we go. Is checking madam. The check for madam required check for ADA because it checked M and M. Then it checked A and A were equal, checked D, and your string is a palindrome. So you got to see the different stages of checking. Okay. Now, so if I want to put functions here, if I want to draw a picture here, well, I can simply use these commands, okay, invocations to realize how this program ran. Here is another very good use for tracing, okay. Let me feed it something that is not a palindrome, okay. So let me give it a word which is not a palindrome. Palindrome is not a palindrome, right? It doesn't match right in the beginning. P is not same as E. So it's not a palindrome. So it should be an easy check. Well, turns out it is not. So this is an inefficient check. It continues to check, continues to check. Why is it continuing to check? It's because our code was inefficiently written. The result is fine. Let's go back to the code. It's checking the inner string first, and then it's checking the outer edges, outer ends. This is inefficient. If you remember in one of our earlier lectures, we said when you want to return, when Python wants to evaluate an AND or an OR, that is Boolean operations, AND or OR, it will only check the first thing first, right? So it's going, my call calls for an inner check first rather than just check the outer ones. So it went through inner check for this one, inner check for this one, inner check, inner check, inner check, until it got nothing, and then it said it's not a palindrome. Okay. Why did it check? It did not just simply check this. It checked this. That was false, and then that was true. This is true. It went here. Okay. So it checked this at the end, and that's useless. Let's do it the other way. Place the outer check first. I hope it's clear why am I insisting on the outer check first, because it should have told me it's not a palindrome right after one check. Shouldn't be inefficiently checking all the inner strings. Okay, so let's place the outer check first. Now let it run. Palindrome. It checked, outer check, and said is not a palindrome. So it checked already. So this is far more. So tracing a code has applications beyond just understanding how the code works. It helps in the efficiency of your code. Okay, you can improve the efficiency of your code. So next lecture I'll continue on tracing our other programs. Okay, until then.